Welcome back. Let's talk about the second half of Chapter 5, starting in Section 5.5 or 5.3.3. And that section deals with what's called list comprehension. And here's the idea. Oftentimes, we have to take a data set, maybe it's a list, maybe it's a file, maybe it's something else. We iterate over it with a for loop, and then based on some criteria, we take elements from that source and put them into a new list. Okay? Or maybe we take elements from an existing source and do some math on them and create a new list. Okay? Something like that. So we can certainly do that with a for loop and the append method of a list. But we can combine those two things together with this concept of list comprehension. Okay? And so basically this is just a simpler way to express the same thing, the process of iterating over a source and creating a new list from that source. So here's the syntax for it, and it looks a little complicated, and it might seem a little counterintuitive, but it's not that bad. So just syntactically, we have square brackets, which indicates that we're creating a list. Then we have an expression, a for statement, maybe more for statements, and finally an if statement. So the expression is going to be something that involves any or all of the loop variables. So the loop variables would be like this: item 1, item 2, etc. We only need to have one for loop. Okay, that would be what would iterate through our original data source, but we might have more than one if we were bringing things together from more than one source. And the if statement is optional. We don't need to have that. So let's take a look at sessions 5.7, 5.8, and 5.9 to see how this idea of list comprehension works. And our sample here is just to create a list of the cubes of the first 10 integers. Okay, so here's the old way, the standard way of doing it based on what we know so far. We would create an empty list first. Then we have a for loop that is iterating over some sequence. And in this case, it's just going over the range from 1 to 10 inclusive. And what it's doing is adding to the new list x times x times x, or x to the third power, and then we'll display that list. Okay, so we'll execute that code and see what happens. Always the first time we run something, it takes a little bit longer, but there we go. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. Okay, so fine, we can do that. But now here's the same thing using list comprehension. Okay, so I still have my for x in range piece. Note that I don't have a colon because it's not a for statement that stands by itself, but that will still iterate x from 1 to 10 inclusive. And then this is my expression. Take that value x, multiply it by itself 3 times to give me the cube. And then the square brackets means that the result would be a list. I'll save that with a variable name called cubes. All right, so this should give me exactly the same result. Okay, so it does. It works exactly the same. And then we can do an if statement in here if we wanted to. So in this situation, now I'm going to take my cubes. Okay, so note that my for loop says for x in cubes. So I'm going to iterate through that. Pick the values of x where x mod 2 is 0. So this will pick the even cubes out of that. And there we go. There's the cubes from the cube list that are even numbers. Okay? So a couple advantages. One is it's shorter, less typing to do. So programmers value our fingers, right, and are preventing arthritis, so less typing can be better. A second issue that's not immediately apparent would be performance-wise, that if we're doing really large data sets, doing list comprehension would be faster, much faster probably in execution than the for loop and append option. Okay, so listing 5.3 and session 5.10 have an improved make data list function using list comprehension, and then sessions 5.11 and 5.12 use that to get some simple statistics on that full earthquakes.csv file. So let's go ahead and take a look at that. Here's our new make data list piece, and the new part is down here, our list comprehension for making the data list. Okay, so this says for line in CSV Reader, that's my iteration, go through everything in the CSV file, and then take the line at that specified column, right, which we found based on the name that was passed in, turn that into a number, make that part of the list, and send it back. Okay, and then notice that it's hard-coded to read from this earthquakes.csv file. So let's go ahead and run that. I'm going to spare you the process of me uploading that file, but in just a second we'll run this function and see how it works. All right, so I've uploaded that earthquakes.csv file, and that is available in the Chapter 5 module on Canvas if you want to upload it yourself. But now when I execute then this make data list piece, let me make sure I define the function. Now I can grab all the magnitudes from that. Oh, I didn't import my CSV. Here we go. I need to go all the way up here and import that. And that's going to be a file not found, but hopefully the CSV piece got imported. Yeah, there we go. So I have 501 earthquakes magnitudes now in my list. And so this will print out the first 10 of those. Okay. Then I can look at the depth from that file. Okay, so 500 earthquake depths. And if I look at those are the depths in some units. I would have to look at the metadata to see what that depth actually is. And then if I try to use it with an invalid column header, I still get an error. Okay, so now let's go ahead and look at the statistics. I make that data list. The maximum magnitude was 7.5. Minimum magnitude was 4.5. Mean 4.87 or 8.8. Median 4.8. Mode, in the book they use the multi-mode function, but remember that that doesn't exist in this version of Python. But thankfully it works for us. Mode is 4.5, and our standard deviation was 0.39. All right, I won't run the frequency table for you, but you could run that yourself. In the next video then, we'll start talking about using JSON and reading it from the internet.